Okay, see you again, guys. My name is Satrio Wicaksono, and I'm here to teach you about the first introduction to engineering design. Okay, our topic for today is about kinematics and biomechanics. This is the expected outcomes of this week. Okay, students able to understand the kinematics principle and its application in everyday life. Okay, you know what is this? You have to know what is this, because I taught you already several weeks ago. This is actually combustion engine. Okay, it has a lot of moving components, and it has specific motion direction and magnitude, and specific motion timing as well. We can study about this in kinematics. Okay, the word origin of kinematics is from Greek. It's from kinema. The meaning is motion. And kinematics itself is part of dynamics, which specialize in motion. Okay, but there are some limitations that are not studied here in kinematics. Kinematics is not concerning about the cause of the motion, and rigid body is assumed. In kinematics, the first thing that you're supposed to study is about degree of freedom. What is degree of freedom? Actually, you can read it by yourself in this slide. It's the number of free parameters to define the every time unique position. Okay, it's showing us the number of motion possibilities. For example, okay, if you look at this case, it's a pencil in 2D plane. If you think about it, there are several ways for this pencil to move. Okay, there are 3 degrees of freedom. The first one is pure rotation. Second one is pure translation in X direction. The third one is pure translation in Y direction. Now, what is this? It's structure design. For structure design, if I ask you how many degrees of freedom it has, what's the answer? Think about it. It's actually 0 degree of freedom. Why? If you have a structure and it can move, for me, I'll be afraid. I'm not so sure about you. Okay, so structure is not supposed to move. So it's supposed to have 0 degree of freedom. Now, we have different case here. Okay, it's a knife. Okay, it's foldable knife. It's 1 degree of freedom. Okay, and what is this? Actually, it's a window mechanism in our car. It has 1 degree of freedom as well. Okay, this one, I taught you about this one last week. This one is the combustion engine. Okay, how many degrees of freedom it has? It has 1 degree of freedom. How about this one? Okay, actually, if you think about it, all structure supposed to have 0 degree of freedom, but mechanism, the opposite, is supposed to have 1 degree of freedom most of the time. Okay, now I will teach you about how to calculate the mobility or the degree of freedom, the number of degree of freedom. Okay, we can calculate it using this equation. It's actually a Kutzbach equation. M equal to 3 multiplied by L minus 1 minus 2J1 minus J2. M itself showing us about the mobility. What is mobility? Mobility is actually the number of degree of freedom. L is the number of link. In Indonesian, jumlah batang. Okay, and J1 is number of joint type 1. joint type 1 is a joint that reduces 2 degrees of freedom. And J2 is number of joint type 2. Joint type 2 is a joint that will reduce 1 degree of freedom. Maybe it's quite difficult for you to comprehend this fast, but I will try to explain more in our study case. Okay, this is several example. For example, this case. Okay, this is a pin that normally used in the door. Okay, it has 2 links and it has 1 joint type 1. Okay, the other good example is this one, roll slide contact. Okay, you have seen it before as well, this one. Okay, it has 2 links, but it only have 1 joint type 2, so it has 2 degrees of freedom. Okay, before you go inside of my class, please study about it first. Try to search for it. What is joint type 1? What is joint type 2? And inside of the class, I will teach you in detail how to differentiate between joint type 1 and joint type 2, and how to calculate the mobility. Because if you just see it from this video, it will be very hard for you to comprehend this for sure. Okay, don't worry about it. And now I will tell you about the use of knowing degree of freedom. Okay, the first use is knowing the certain mechanism motion. Okay, and the second use of it, it's very important, is to design a particle mechanism that can produce particular motion. Okay, this is several example. The top one is flap mechanism in aeroplane. Okay, and the bottom one is tractor with loader. Okay, I want to ask you about something. Please think about it first before you join my class. Tractor with loader. How many degree of freedom it has? I will ask you that question inside of the class. Please try to search for it first. Try to calculate it first, and later we will discuss about it. Okay, the next one is biomechanics. Okay, we are going to the second stage. Okay, biomechanics. What is biomechanics? Biomechanics is knowledge that study the mechanics of biological system or living things. Okay, there are several applications. Sports. Okay, in sports, biomechanics is used to improve athlete performance and health related as well. Okay, to analyze people's health and to improve people's health. And this is one of the example. Walking motion analysis, or in biomechanics term, we call it as Gait. Okay, we can gather motion information, and after that we can convert it, we can translate it into force. Okay, I will discuss it in detail inside of the class. Actually, that's all for today. I hope you can study first before joining my class, and see you in the class.